We are in investigation 1.4 of variables and patterns, and in this investigation we are looking at day 2 of our bike tour, and our warm-up for this morning is up here on the board, and I'm passing the handout out to you. And the first question is, the graph below shows the relationship between two variables. What are the variables? So if you remember, all we're really trying to find out is if looking at a graph, you can figure out where you find the variables. So the variables are day and number of cans collected. So the variables are always listed on the X and the Y axis. All right, where day is your independent variable and number of cans is your dependent variable. All right. Part B, on which day were the most cans of food collected and how many cans were collected on that day? All right, so in order to figure this out, we have to look at the actual graph. And if we look at how the graph is set up, the days are each day, and then it says how many cans are collected for each day. So when reading this graph, you're not going to go to the end and say, oh, it's day 5, because that's the last one. We're not reading the graph from left to right. This is a graph that you have to actually read it up and down. So the day that we collected the most cans is actually day 1, because that's the highest one up. And the amount of cans that we collected is, we're going to have to estimate, so we'll say it's about 79. All right, so you can say 79 or 78. Probably won't go much lower than that. All right, since it is counting by tens, and so therefore each space in between has to have 10, so it's not going to be that much of a difference. All right, C. Oh, I'm sorry. The day is day 1. Almost forgot that, and that's the importance of reading the question. So on which day, and then how many collected on that day. Okay. So 2 questions, 2 answers. All right, part C. What total number of cans was collected over the 5 days? And explain your reasoning. So over the 5 days, so thinking about the graph, each day is a separate collection. So what we're going to have to basically do is add it all up. So we'll take the 79, which equals day 1. And for day 2, that looks like it's 60. 60 for day 2. Day 3 is the same thing. 60 for 3. Day 4 is looking at about 32. And day 5 is looking at about 65. So when I add all that up, so add up and equals, and again, as long as I'm saying what I'm doing, it's okay for me to use a calculator for this. So 79 plus 60 plus 60 plus 32 plus 65 equals 296 cans. And as I said before, using a calculator for this type of a problem is okay, because you're just adding it up. That's fine. I'm okay with that. Part D. We're skipping part D. Okay? I'm not going to worry about the mean right now because we're not really focusing on mean, median, and mode. All right, E. On this graph, does it make sense to connect the points with line segments and then explain your reasoning? All right, so if I look at the graph, and if you remember, in order to determine if you can connect the points or not, you have to think about the variables. Day is the first variable. Can I break a day down? Yes, I can. I can break a day down into hours, minutes, seconds, so that works out okay. Number of cans collected. Can I break the number of cans collected down? Meaning, can I have less than one can? I can't. I either have a can or I don't have a can. So the answer to the question is no. The reason, I'm not going to write it because I don't have enough space, but the reason is because the number of cans collected is either a whole can or it's not. There is no in between, there is no 1.5 or 1. Alright, so that takes care of our warm-up, and the next video we'll get into the actual lesson.